What's going on, everyone? In this video, we're going to be taking a look at two examples of when we use the inverse trig function. Okay, sometimes it's a little bit complicated for students to wrap their head around, but I promise that as long as you follow these steps, you're going to get these problems right every single time. Let's go ahead and do that. All right, so here we have a triangle ABC, where the angle ABC is 90, okay? So I have angle ABC is 90 degrees, 5 is my hypotenuse, and 3 and 4 are my legs. Now, we want to find the size of angle A. So we want is this right here. We want this theta, that's angle A. So you can use really any trig function because we're given all three sides. So if I did the sine of theta, that would be equal to, let's see here, opposite over hypotenuse, 3 over 5. If I wanted to do the cosine of theta, that would be equal to 4 over 5, adjacent over hypotenuse. And finally, we'd have tangent of theta would be equal to opposite over adjacent, 3 over 4. Okay, we can use any one of these. It doesn't matter. But I'm going to choose tangent. Okay, again, it doesn't matter. So what I want to say that, okay, tangent of theta is equal to 3 over 4. Okay, so how can I get rid, or I shouldn't say that, how can I isolate for theta? Well, I'm going to take the inverse tangent of each side. Because if I take the inverse tangent of each side, what that's going to do is inverse tangent and tangent are going to kind of cancel each other out. I'll be left with just theta, and that'll be equal to the inverse tangent of 3 over 4. And then what would that be? Again, all you have to do is go into your calculator. For me, it looks like this. I would do the inverse tangent of 3 over 4, and look at that. What a coincidence that it was the last problem I just went over in the previous video. 36.9. So theta would be equal to, theta would be equal to 36.9 degrees. And you'll find that if you use any of these, it would be the same exact value. So for instance, if I did algebra and I kind of whittled this down, this would now be inverse cosine. Theta could be equal to inverse cosine of 4 over 5. So if I went into here and I did the inverse of cosine and then I did 4 divided by 5, same exact value. Because again, these properties hold true for every triangle. It's just the ratio and the ratio of the two sides that you're taking into account. Okay, so again, 36.9 degrees. There's your answer. Simple enough. Let's take a look at one more. All right, so now we have someone, Emma, who is standing in front of a really big tree. And she's going to measure her distance from the tree as AB, and that's going to be 15 meters. She also finds that angle A is going to be 40 degrees. Now, what we want to know is BC. So basically the height of the tree that's kind of above her, you know, starting where the bushes are. So what is BC? So we want to know what BC is. Sorry, let me get pink out. So what we want to know is what is BC. I'm going to highlight this in pink to make it stand out. What is that? Let's call this, I don't know, H for height. You can call it X. You can call it whatever you want. So what trig function would I take into account? So I'm thinking about SOHCAHTOA. I know that this is going to be my 90-degree angle. So this is my hypotenuse. I'm not taking that into consideration here. I am taking the opposite side of the angle and then the adjacent side of the angle. So that's going to be tangent. So I'm going to have the tangent of 40 is going to be equal to the height all over 15. And that would give me 15 times the tangent of 40 is equal to h. So what is 15 tan 40? We're going to find that h is equal to 12.6. Okay. So again, hopefully that didn't catch you too far off guard because I know we didn't use the inverse trig function there. Just remember that whenever you're looking for a side, you are not going to be using the inverse. You're going to be using kind of the regular trig function. Then when you're looking for the angle, you'll be looking for the you'll be looking to cut that. So hopefully that didn't confuse you too much because I know we didn't use the inverse trig function here. Remember, whenever you're looking for a side or a missing length, you're going to be using the kind of the regular trig function. And then when you're going to be finding the angle, that is when you'll be using your inverse trig function. And just to quickly prove that that is the case, let's say that our height is 12.6. And then our base going left to right is 15. So again, tangent, and let's say we don't know what the angle is, even though we do. That would be opposite, which would be 12.6 all over 15. And now this might give me some weird answers just because I rounded a little bit in my previous one. But as long as it's close to 40, we know we're on the right track. So let's see if that in our calculator does in fact give us 40. So what we do is go to our calculator. We would do the inverse tangent of, 12.6 over 15. Of 12.6 all over 15. And that's going to give us 40.03. Okay, close enough. Again, that's just due to a rounding error. But yes, we're close enough to 40 to know that that is indeed going to give us an angle that is going to be 40 degrees. So that's kind of how these two go back and forth. The regular trig function is going to be giving us the missing side. The inverse trig function is going to be giving us the angle. So I hope that provided a little bit of clarity as to why we use a regular trig function, which is to find the missing side, and when and why we use the inverse trig function, which is to find the missing angle. That is your scenarios in these kind of problems, and I hope that shed a little bit of light into it and which one you should choose. Okay, no need to stress out about that on a test. So I hope that helped, and I'll see you all in the next video. Take care.